It's 2021, and C today is not your granddaddy's C. Language, or at least the way that we write it, has changed a lot in the last 49 years. And so I figured what better way to kind of talk about the way a lot of people write C. And I don't want to say everybody. It's not like there's some sort of uniformity to this. But at least in my neck of the woods, sort of the way that I see more and more people coding C in 2021. And what I mean is, though the language itself is still pretty similar to what it was back in 1972, the way that we write it and the way that we go about problem solving it has changed. And I figured what better way than to go write some demos. And I was talking to Moki from VR Chat, and he just kind of offhandedly mentioned, like, could you write an overlay, like an OpenVR overlay for virtual reality in C? And the answer is yes. And in fact, it's actually not that hard. And so I figured I would do video of me doing just that. Now, before you're wondering, I already had practice. This is going to be the second time I've recorded this because the first time the audio didn't turn out. So I've already done this once before, so if you think that I'm going a little fast, it's because I already have the experience here. And so what we're going to do is we're going to kind of go two parallel paths. We're going to go do this both in just Notepad++ and TinyCC, so no IDE, tiny little downloads, really just if you want to go code something quick in C and you don't want to have a bunch of stuff installed and all that, we'll just do it that way. And then the other way that we're going to go about it is we're going to get GCC and Visual Studio Code and make a project in that. And I think that that's actually where we're going to go code this actual thing. So yeah, let's get started. Okay, Charles from the future here. Number one, this is not a talk or a presentation. This is just me getting the stuff set up and going and writing an OpenVR app from start to finish. So the first 12 minutes tells you how to set everything up, and then the last 40 minutes tells you, well, it's just me making the OpenVR application. Next thing is, all of the instructions will be in a gist. If you don't want to watch this whole video, you can just click on the description and click on the gist and just follow the instructions. It's in plain text. It's really simple. I show two completely separate ways of doing things, one with Notepad++ and TCC, and another with Visual Studio Code and GCC. They're completely different. You can do exactly the same thing in either one, depending on which way you want to set up your development environment. A side note, you don't actually need to do all of the OpenGL stuff to make a OpenVR app, but I promised Joe Ludwig that I would. One more note, because I'm also working on a video on modern idiomatic C, if you're a C programmer and you have some opinions about the direction that C is headed in 2021, please join my Discord so we can have some input and get together a really good video about where C is and where it's headed. Without further ado, alright, so on this system I've done just about nothing. I've installed Firefox, SteamVR, Space Pirate Trainer, and OBS, so I can just do this recording right here, the application I'm recording with. So we're going to go from basically nothing to everything in this. I'm going to step through every single part. So to do this just the sort of bare bones way, I'm going to go get TinyCC and Notepad++. So I'm going to download TinyCC download, and I'm going to go np++ download, np++ download. So we're going to go get these two. And by the way, the reason the links are purple is because I've already done this before. Don't worry about it. I'm not cheating that way. So for TinyCC, we'll need two things. One is we'll need the TCC 0927, the actual application, and we'll also need the WinAPI full. And so that's so we can write Windows applications. So that's like, I don't know, 5 megabytes of downloads right here. And what I'm going to do is I'm going to make a new folder on my C drive called Tools, and I'm going to go put TinyCC there, just because it's a convenient place to put it. So I'm going to get TinyCC, and then I'm going to go overlay the Windows API full, replace. Okay, and then the next thing I'm going to do, which is a little bit odd, but I'm going to go add that to my system path. So C:\tools TCC. And what that's going to do is make it so if I run a command prompt and I say TCC, you'll see that TCC is now installed. So I unzipped it, I'm running it. I'm going to make a file called, actually, let's go get Notepad++ installed. Boom, there it is. Save, Go, done. Let's get this thing installed. English. Yep, I agree. Yeah, sure, whatever. Yeah, we're good. Okay, and we're going to run Notepad++. And so what I'm going to do is I'm going to say Notepad++ hello.c. Oh, I need to add Notepad++ to my install path thing. So program files, Notepad++. Let's go add that to advanced environment variables, path. Boom. Okay, so now from the command line, I can type Notepad++. I guess I could also just make a file, but test.c. Include hello, or stdio.h, int main, printf hello world, return 0. Okay, so now what I can do is I can say TCC test.c, and it built test.exe, which is right here. So it's a tiny little 2 kilobyte file. You can type in test and it says hello world. So now we have a fully functioning C development environment set up. It's just not a full-on IDE, but we can write really simple applications, which is great. All right, so the next thing we're going to do, now that we have a little IDE set up with tiny CC, so we can at least compile C programs, let's go get the heavier environment. Let's go get GCC and VSCode. So Visual Studio Code, and then let's go to download. And here we're going to use the system installer, because if you do it as user installer, it installs the user thing. It's annoying. I don't like doing it. And we have to get GCC min-gw download 64-bit. I think this is it. From min-gw-w64.org. Where's the download button? Downloads. Sure, whatever. We'll just try it. min-gw-w64. Okay, yeah, min-gw-w64 install.exe. That's the right thing. Okay, let's go get that. Let's install min-gw first. And we're going to have to select specifically what we want. So we want x86 64, because we're only going to be building 64-bit apps. We're going to be using SEH, I believe, for the threads. We're going to use Win32 threads, and I guess that's it. I guess that's what we want. So Win32 SEH. Okay. Is there multiple? Nope. Okay, let's just go for it. And we'll actually download this to the tools folder because I hate having spaces in my file names. Okay, so that's downloading that. Now let's go over to Visual Studio. Oh, that's already there, so let's install Visual Studio Code. Yep, I think all the defaults are kind of what I want. Okay, so that's downloading and doing the thing right now. Actually, I guess it's not downloading, it's just installing. The installer came with the downloads. Oh, God forbid, 2020 somebody does that. Anyway, downloading now. I could launch Visual Studio Code. Yeah, let's do that. We're also going to have to close Visual Studio Code because we have to put min-gw TCC in our path. So it's still installing, but it's going to put the compiler in this bin folder. So advanced system settings, environment variables, path. Let's go add that too. Okay, we have a bunch of stuff in our path now, which is nice. So okay, next, finish. Okay, so now if I go to command line prompt, I can say GCC hello.c-o hello.exe. Oh, is that not it? Oh, it's test.c. Test.c-o test.exe. And so now it's 54 kilobytes because GCC just produces big executables, but I can say test. And actually, GCC doesn't have to produce big executables. I can say dash like OS for small code and dash S to strip out all the bug symbols. And then it's 15 kilobytes. So it's what, 7 times the size? It's fine. Still works. Still can print hello world. Okay, so now we have GCC, TCC. Those are just 2 different options installed. And let's go to Visual Studio Code. Okay. And we're going to, let's make a new folder. I'm going to call it New Folder Projects. And in here I'm going to make a new folder called Hello. And what I'm going to do is File, add folder to workspace. And so we're going to add hello to this workspace. And we're going to go create a new file. So this is now all in Visual Studio Code. It's a nice IDE environment. It works on Windows, Mac, Linux, all of them. We're going to make a new file, hello.c. I'm going to rewrite the thing again. So pound include is just like the using directive in a couple languages. It just says, please get everything in that file and put it in here. And then I can say printf hello world. Okay, and cool, return 0, done. So now there's 2 additions we're going to need for Visual Studio Code. One is C and C++, this one right here. Oh, I guess I'd already installed it. So we'll uninstall and reinstall. And Code Runner, which I have already installed, but we'll uninstall and reinstall. Again, it's my 2nd time through. You do need these 2 packages though, but that's it. Okay, so hello, and now what I can do is I can do Control-Shift-B, and it's going to automatically find the build environment for me. So in this case, we'll just do GCC. So we just click that. It now knows how to actually build, and it built it successfully. And if I say over here, run and debug, I can select C++, GDB, LDDB, and we'll say, yeah, same thing, GDB, and it produces this little file right here, this launch.json, where it says like, yeah, we're going to use GDB, it found GDB, it knows how to do all of that, okay. And so now if I press F5, it's going to run hello world, and it's going to print it out to the terminal right here. And so I can do something a little bit more interesting, like int I printf hello world %d I. Oh, we have to initialize, so I equals 0. Okay, so we're going to go build that, and I'm going to go put a breakpoint in, and if everything works, aha! Now we have breakpointed on this. We can step to the next line. We can look at what the value of I is. It's 0, and if we step ahead, now it's 1. And now it prints out hello world 1 to the terminal. So now we have a full IDE environment which we can debug in and everything else. So this is just terminal applications, but we're going to go write an OpenVR application to monitor the battery values of our controllers. So let's just go finish this. Okay, we're good. So the next part that I'm going to do is, I guess I'll make a new folder, and we'll call it OpenVR battery. Actually, let's just call it OpenVR battery monitor OBM. Sure, we'll just call it OBM. Why not? So let's go Visual Studio Code, and we're going to go select this path. Oh no, file. There we go. Open folder. Boom. OBM. Select folder. Nope, don't want to save it. Okay, so what we're going to do is we're going to make a new folder, or a new file called obm.c, and we're going to do the same thing again just to make sure we can just wake up. Okay, return 0. Let's make sure we can still build it. So we're going to do Control-Shift-B. Because it's a new project, we have to reset up the build script, which just did. And because it's a new project, we're going to have to go reset up the debugger. Okay. One of the things that you should be sensitive to is when you're using these add-ons to do the really quick stuff to make it so you can build, like Code Runner, you have to be on the file you want to execute. So you can't be like at the welcome screen and press F5. It doesn't know what that means. But if you're on OBM and you press F5, it knows exactly what that means, and it's going to go print hello world. So how are we going to go write this application? So I do have some notes cribbed. And so what we're going to do to write this application is we're going to first need to make a window. We're going to need to be able to have some way of creating an OpenGL context in Windows. There are libraries to do this, which you would have to actually have a library for, like SDL, but that's not in the vein of C development in 2021. Instead, what we do in 2021 is we use something called header-only libraries. And so the one that me and a bunch of other people from my Discord server have gotten together and written was called rawdraw. This is just an advertisement for rawdraw, I guess. But if I go to github.com/cntools/rawdraw, there's a file called rawdraw_sf.h. And what this is it's a single file, SF header, that contains all of rawdraw for every single platform. And so rawdraw is just a way for you to create a window and OpenGL context and draw in immediate mode and a bunch of other stuff for Android, Windows, Linux. It runs the same on every system. So I'm going to just say raw, and then I'm going to go save this to rawdraw_sf.h in this folder. So now I have rawdraw_sf.h. We're going to go #include rawdraw_sf.h. And one of the nice things about these header-only libraries is usually they contain a sort of like hello world. This one doesn't, but if you look at rawdraw itself, there is a hello world right here. It's just an example program. So I'm going to just copy and paste this example program into Visual Studio here, Visual Studio Code. And I'm going to say Control-Shift-B. There's errors. So in Windows, we do need to actually include a couple libraries, but that's really easy to do. So if we go over to Files, VSCode, Tasks, we can have this stuff here. This is how it actually builds it. So we're going to include a few things. -L kernel 32, -L user 32, and -L gdi 32. And that's the libraries in Windows to tell it how to actually build things. Not build things. It's the libraries in Windows to tell it how to like open a window and stuff like that. So let's see, what do we have to do here? Oh, I had tasks.json up when I tried building. That won't work. But now that I'm on OBM, I built it and it built successfully. And if we run it, now all of a sudden we have a hello world application. Hello world, all of this. It's this code right here. Now we don't actually need hardly any of this. All we're actually going to do for right now is, I don't know, create a window and then let's make it much smaller. Let's just say 256 by 256. We're going to clear the frame, handle any input. We don't need dimensions. Let's change the color to white and let's print hello world. Let's do none of this other stuff and then just swap the buffers. Okay. So we're going to build this and run it. And so now we have a hello world application. Oops. So that one looks like it's up and running. Let's make sure that I'm still recording okay. I am. And it looks like the audio is fine. So we're going to go close that. So that worked again. So now we have a Windows GUI application. We could do things like detect mouse movement and stuff like that. But so now we have ready to go this application. And so the next thing we're going to want to do, I guess, is probably let's go make an OpenVR overlay. Why not just beeline this to where we're headed? And so in order to do that, we're going to need a few other things. We're going to need a copy of GitHub Valve Software slash OpenVR. So in OpenVR, there is headers and then OpenVR C API. So we're going to go download this to OBM. And we're going to need a copy of the library. which by the way, you only actually need the DLL if you're compiling using GCC or TCC. But usually I download the DLL and the library in case you ever want to use Clang or Visual Studio's tools. So let's go copy this into here, and let's go get the library. Lib Win64. Which honestly I think libraries are annoying, but whatever. Just for the sake of making it so that this could also work with Clang, I will show how to do that. Okay, and so what we're going to do now is pound include OpenVR capi.h. There's a bit of an oddball thing here. We do need to say extern C, I believe. Actually, what happens if we don't? Let's just try this and see if it explodes. Yeah, pound undef that. Okay. Okay, so that built now. So OpenVR capi. This is done a little bit weird. This isn't really that idiomatic of today's stuff, but they want you to put the API stuff in your own application. But we can do that. So just delete the SAPI stuff, and we're good there. And so what we're going to want to do is we're going to need two global variables. We're going to call one, let's see here, what is it? It's VR, hello, why aren't you syntax highlighting? Okay, there we go. Oh, system, and we're going to also want the overlay interface. Yeah, we need the struct in front. That's weird that the syntax highlighting isn't getting it right. VR overlay fn table overlay. Okay, so then what we're going to need to do is we're going to need to set up the window. So that'll give us an OpenGL context. Oh, it won't give us an OpenGL context. We need to tell it we need an OpenGL context. CNFG OGL. And so what that'll do is instead of opening a Windows window, it'll open an OpenGL window. Oh, and we need to also include OpenGL to our build. So L OpenGL 32. Okay. Okay, so now this is an OpenGL window. And then what we're going to do is initialize OpenVR. And so in 32, well, actually, let's just assume everything's going to be fine. So VR init internal, and we're going to pass in error E. Oh, one of the other neat things about more modern C is that pretty often what people will do is they'll put code inside of blocks, and what this does is it makes it so that the scope of the variables stays within the block. So it's like writing a thing as a brand new function, except instead of having to go jump around the code and noodle around to figure out how the program's executing, it's like a function inside of the current function, and you can just follow the code linearly. It's just a lot easier to figure out what's going on. And what we're going to do is an EVR application, and we're going to do VR application type overlay. There we go. So we're making a little overlay. And what we can do is we can say if E is not equal to, shoot, what is it? They're initializing OpenVR code, and we'll just print out the error code. and then we'll say return -5. Tell whatever application calling us that we had an error. Okay, and then we can say printf OpenVR started successfully. Okay, let's run this. Uh-oh. Ah, I need to go include the library for OpenVR API.lib. Not found. Is this running from a weird folder, maybe? Let's just see. Okay, I don't remember. That's odd. Whatever. For right now, we'll be fine. We're still linking to it. So if we run this application, it starts the thing. It says OpenVR started successfully. So now we have an application, created a window, initialize as OpenVR. We're doing okay in the world. So now what we're going to need is to get access to some of the system functions and the overlay functions. So as before stated, I already have an overlay and a system thing. So I'll say overlay is equal to struct. Actually, let's copy paste this down below so we can go crib it real fast. overlay is equal to, and we're going to use the oh, we gotta write like a function to actually, so we could just straight up get it, but it's easier, I think, if we write a function. Or is it? Yeah, let's go write a function to do this. Okay, void star, actually, you know what? I've already written a function to do this. Let's go copy it. Get function table. There we go. It's got to be changed a little bit because that system used a different thing for printf. Other than that, I think we're fine. So let's just use that. Okay, so, and we're gonna, what we actually want here is we want IVR overlay version, and we want O system. Okay, and what we're going to do is just make sure both of those exist. Overlay and O system. So what these are actually just like function tables. So you just use this function and then it'll get you the a table with a bunch of other functions that you can go call. And so that all of these, like get overlay flag and all of that, will be populated with safe to call functions. So let's go build this, see if it still builds. Okay, let's run it. And it says, okay, yeah, it looks like we've got a thing here, and it looks like it's outputting stuff okay. Let's go put a new line there. Okay, so actually we should probably error out if either of those don't work. So if not O overlay or not O system, meaning that if the pointer is invalid for either of those, printf error getting function tables from OpenVR. Return -9. Okay, I just made up some error code for return. Okay, I guess the next thing we should probably do is create the overlay. So O overlay arrow create overlay, and we're gonna go call it OBM test and OBM test. So the overlay should be overlay and we'll need to pass in a handle. Overlay handle, actually UL handle. Okay, let's go make a handle for ourselves. And I believe this is, let's see, what is this type? I believe it's a UNT64T. Oh, it's just a VR overlay handle T. Okay. VR overlay handle T. UL handle. Okay. So now we have the handle. And let's go assume that that works. O overlay, and then we'll, let's just set the set overlay width in meters, UL handle, and it'll be, I don't know, 0.2 meters feels like a pretty, 0.3. Let's make it a nice big overlay. Overlay, set overlay color, overlay, no, I mean, sorry, UL over handle, and then one for red, one for green, and one for blue. So it'll make it nice and solid. And then this is kind of annoying because we're doing the OpenVR, OpenGL overlay. Instead of doing a raw overlay, we do need to actually set the bounds for the texture. And so that's a little bit, oh, good grief, Friday. That's a little bit weird. But what that is we'll say struct VR texture bounds T, bounds dot u min is 0, bounds dot u max is 1. Why is this not? Ugh. Is that valid? Yeah. Bounds dot v min is 0, bounds dot v max is 1. So that just says how to actually like set up the window, so that like our texture we're submitting will be on the middle of it. And then we will say overlay set texture bounds, and we'll pass in UL handle and bounds. Okay, let's then, I guess, show the overlay. Overlay, show overlay handle. Okay, I don't know that this will work. I don't know where it's going to put the overlay, but let's just run it and see anyway. So it should just be white, and I believe it should just be... Oh, don't see it. Okay, maybe we actually have to go put a texture on it. Okay. So to do that, let's also GLU int texture okay, then we have to go copy paste from Stack Overflow. It's like GL texture mag filter. There's like something with that. Example. Now let's just do this, copy and paste. Oh yeah, let's just copy all of this. So the idea is we're just creating a target texture for us to go like write our thing into. And what we'll also do is we're making pound define width and height. Okay. Oh, it's still running. Let's try it again. Okay, F5. Okay, so we were able to create the texture. So I guess the next thing that we're going to need to do is submit that texture. So we draw, we swap buffers, So we want to make this little blue window right here appear in VR. So this little hello world thing. So maybe this is a little weird, but it's going to be like GL bind texture, this texture up here. No, wait, not one. And then, okay, so this is the thing I have to actually go look at the command for. GL copy text image 2D, GL texture 2D, level will be 0, GL RGBA, 0, 0, width, height, 0 for border. And then what that does is it takes the current window, this sort of blue window, and copies it into a texture so we can go hand it off to OpenVR. Overlay texture. Oops. I misspelled that. Dot color space is here we go. Heat texture type. No, that's, I don't want that. That's the type. So overlay texture dot color space is, oh, it's like an E color space auto. Whatever. Overlay texture dot handle. It's going to be our texture. And then what we can do is we can say overlay submit it's set overlay texture, no, not bounds. I think that'll do it. I have a warning, don't we? No, we're good. Okay. Oh, I see it. Let's go show that. So right there on the floor, a little hard to see, is our Hello World texture. So we have an overlay in OpenVR that is a Hello World overlay. Okay. So next, we're going to want to attach that to our wrists. How are we going to do that? Let's see, how did I do that before? Okay, so we're going to go write a function to do this. It just is going to be easier that way. Int associate overlay, and then it'll be, actually we already have the handle right there, so we're just going to do that, and it's going to return 0 if it fails, or 1 if success. Okay, and then we're going to also want to have a variable somewhere that was like int has associated overlay. Okay, and if we have not associated the overlay, then and actually that's backwards. Idiomatic C here. 1 if fails, 0 success. Okay. And so in here, what we're going to do is we're going to have to do a little bit of tricky stuff. I have already coded this before, so I'm going to be cribbing off of that a little bit. So first of all, we need to know device index. We're going to need to know what the device index of the controller we're going to want to be associated with is. So the idea is like I want this to appear on the back of, like, backhand of the controller. Oops, whoa. Okay. And what that would be is, actually let's go, yeah, let's leave this up here. And we're going to do this on the left hand. And then what we can do is we can say left hand ID is going to be OSystem, and it's get tracked device ID from controller role, and then it's going to be tracked controller role left hand. Okay, and we're going to say if that's not equal to 0 and that's not equal to -1. Actually, so if it's equal to 0 or -1, then we're going to return an error code. Otherwise, we know that we have a valid handle, and we are going to create a transform and associate it with it. So struct we're going to make it an identity matrix. 2, 2. Okay. Why is there? Okay. And then what we're going to do is we're going to say, oh, overlay. Friday, what is up with you? Arrow, and then it's set overlay transform tracked device relative. Handle is UL handle. Track device is left hand ID, and then transform. Okay, I think that's it. Let's run it and see what happens. Oh, there it is. Oh, whoa, whoa. What is going on? So now I have this thing on my hand, which is this battery monitor, but it's not a battery monitor yet. It just says hello world. So now we're going to need to make that actually have battery information on it. Okay, so we'll do that down here. Actually, tell you what, let's instead of doing that, let's try to fix up the thing here a little bit. So actually, I think what I really want to do is 2, 1, and 1, 2, because that's a really awkward way of holding it. Oh, that's a warning. Whatever. Get rid of that warning. Doesn't matter. It's just saying that it's weird that it's... Yeah, whatever. Don't know why that was complaining. Okay. Let's go see what this looks like. No, now it's all wrong. It's upside down even. Okay, let's just leave it as the identity matrix. We'll worry about making somebody else's problem to go fix that up and make it look good. Okay, so what we're going to do now is instead of printing hello world and making it a dark blue background, we're going to just make it a black background, and we're going to iterate over the devices. And so what we can do then is int I for I is 0, I is less than 64, because we're never going to have more than 64 devices, I++. And then, actually, there's a constant for this. What is it? Yeah, oh, it is. It's exactly 64. Okay, so track devices, I++, and then what we're going to have to do is get the battery value for that track device. So system get, so one of these is going to be like a float, get float, track device property, and then we're going to look in here for battery. It is battery percentage float. And device index will be I float and ER. So I need to make an eTracked property error. Okay. And so if error is 0, then we know that that was okay. And we're going to make a new variable called int device num. So say which line we're going to be on. We're going to say, well, let's get the name of the device too. Yeah. Chart dev name, system get string track device property, oh gosh, what is that called? String. Yeah, let's do that. So if there was an error getting the name of the device, we don't want to deal with it. Otherwise, let's do char st 250. Okay, what before. And so we'll print out the percentage of the battery, and then the name of the device, and that would be times 100 and dev name. And then what we're going to do is we're going to use the device number to decide how to CNFG pen x is, let's make it 1, CNFG pen y, let's make it 18 times device num. And what we can then do is CNFG draw text st, and we're going to go make that size 2. Why is that erroring? You know full well that that's right. Oh. If error. Okay, I don't know what I was doing there. Oh, that's right. So this wants to be an int pointer. Okay. Oh my gosh, this is so annoying. Void start. Okay. Let's go. Oh hey, there we go. So knuckles left and knuckles right, and 87 and 91. And so now in VR, I can look at my knuckles anytime I want and see how much battery is left in the batteries. So I'm going to be playing the game and see that I still have a lot of battery left. Let's make this transparent. So we should be able to do that by setting the background to transparent. Yep, there we go. So now we have the transparent thing with the battery. Okay. Let's get rid of the words "Hello World" because that's dumb. Okay, and one please. Let's go actually fill it in. So let's go draw a box right behind it based off of how much battery is left. So if bat is greater than 0.4, then color. Let's make it green. Let's make it kind of a dim green. Else, if it's greater than 0.2. Else, if it's greater, or just else. Make it red. So we'll make it yellow if it's low. And if it's about dead, we'll make it red. We're going to make a rectangle starting at and going to, let's just start at 0. And then the height of it will be 19. CNFG color. That's bright white. Okay, let's give this a shot. There we go. Something's wrong though. There's only the one green bar thing there. Why does it only have one green bar? Oh. There we go. Yeah. Yeah, that should do us. Let's make it only 16. Boom! Let's give this a shot. There we go. Look at that. You may want to tuck the text down a little bit. Looks like it's working. Though there's a problem, so it's running really janky. Let's see, advanced frame timing. Well, it says it's fine, but it's definitely not running fine. Tell you what we're going to do. We're going to go print out the frame number. And we're going to start at device number 1 because I do want to actually go print something. Because I think what's happening is we're probably running at 1000 FPS, and that's just making the rest of the system mad. Oh, have to increment frame number. Oh yeah, we are easily running at 1000 FPS, and that's going to make the rest of everything sad. So down here, we're just going to go say sleep 20. Actually, let's make it 200. Batteries aren't going to change that fast. Okay, and so now it is not updating very often. Everything is nice and smooth again. And I can look at the battery on my controllers whenever I want, and it's nicely attached to the device. I could probably tweak with the way its appearance is, but it is definitely working. So, yep, that's how we write an OpenVR application in C in 2021.